but maybe my motor's only burning up 600 watts of power. I'm applying twice as much as I really needed, because my power factor was probably like a 45-degree angle in that case, right? It's 45. So by applying a capacitor, what I can do is I can get this closer to where now I actually only need, I still get 600 watts out, but I only need an apparent power of close to 600 volt amps, because it's almost entirely real. Well, 600 volt amps out of 120, that means I just dropped my current in half. That's a lot better. I'm using a lot smaller wires. I'm drawing much less current from the power company. I'm paying less. The power company measures how much current you draw. If it's having to supply a huge current to you and you're not using it, that's not their problem. However, it is their problem because they don't want to have to supply any more current than absolutely necessary, because that means they have to upgrade their system to handle all that extra current. So what makes this, one of the things that makes this really cool, there's some, well, here's some, that's extra application, it's fine. But one of the things that makes this cool, I actually had one of my students in this class a couple of years ago. He worked for United Illuminating. His entire job was power factor correction. He was in the system all the time looking at utilization of current and measuring the power factor in the system. And United Illuminating has something like 10,000 capacitors in these capacitive banks distributed across their system. And they turn the capacitors on and off to add in shunt capacitance to the system, so that if like a big factory turns on, a whole bunch of motors, suddenly wham, stupid reactive power goes through the roof, UI turns on a whole bunch of capacitors to counteract that, near as close as possible to the actual factory, right? And in fact, they also have engineers who work with factories to design power factor correction systems for their plant, because United Illuminating will still charge them for whatever they're using, right? But again, they don't want, United Illuminating doesn't want to have to provide that power and provide larger wires and all of that, a bigger power substation than it needs to, because that costs a lot of money, right? So they'll work with a factory to add power factor correction at the inlet of the factory. So now the factory gets the economic benefit as well as United Illuminating, right? And so it helps everybody out to do power factor correction. This happens on an individual motor or on your refrigerator. So if you're tasked with designing the electric motor system on a refrigerator, you can say, oh, I can reduce the total power that this thing has to be able to draw by adding a capacitor to reduce the power consumed by my motor in my compressor, right? So it's a really, really useful thing. I mean, again, Marco's whole job was power factor correction. He is probably still, I don't know, maybe he's changed jobs now, but he's still UI. But anyways, that's how important it is that they have banks and banks and banks of these capacitors out there, and they have to monitor them constantly. They have computer systems and everything they've designed to do this automatically, but people have to be involved to maintain this system constantly, because otherwise they could overload their entire system. So power factor correction is pretty cool. All right, I think we'll stop there.